All right, welcome to Lesson 6 of our Bootstrap course on Native SDK. This is a continuation of our discussion of cross-chart filtering. Last time we discussed the high-level picture of what goes into cross-chart filtering, and I showed you how to set up an example which meets the prerequisites for cross-chart filtering. Namely, you need to have a data source that more than one chart is using. Because only if you have a data source that is shared between multiple charts can you cross-chart filter the data between each chart and see, okay, this chart gets this part of the data, this chart gets that part of the data, we're filtering on a common data source, so forth and so on. Today, we're going to look at how to implement the core cross-chart filtering functionality, though. So, let's go ahead and get to it. Now that all the prerequisites for cross-chart filtering are in place, we're going to start building the core cross-chart filtering functionality. And there's several components to this, as we've discussed, but the one I'm going to start with is the filter conditions. So we're going to deal with what can the charts do when you interact with them so that there's some conditions we're supposed to filter by. And then we'll proceed through the diagram in that order. So once we have the filter conditions, then we'll perform the actual data filtering. And once we have the data filtering function implemented, then we will deal with generating the different data sets required for each chart. So that's how we're going to go through this. That's the game plan. So the main thing for filter conditions is we need to detect when the user has interacted with one of the charts, and we need to specify what should the new filter condition be based on that interaction. So I'm going to start with a time chart, and this is going to use, no surprise here, the events. And the way I'm going to do it is, to start out, I'm just going to base this on selection. So this is going to be on selection change. And that, well, that's how it's going to work. I'm going to select part of the chart, and we're going to consider this the part that is supposed to be filtered. This isn't necessarily the only case you would want to apply some cross-chart filtering in. Maybe, for example, if I zoom in, I would want to filter based on only the visible range. But we're just going to start with selection. We're going to keep it simple and go from there. Now, once we're in here, how do we determine what the filter should be? Well, of course, we're filtering the time, right? We're filtering based on what is within the time range. So it's going to be a filter on the date, and it's going to be between the selection start and the selection end. Now, there's a few ways you could do this. One way is you could access the selection start and end from the args. You could also use the args.chart.selection API. And I'm just going to, there we go. And that's totally fine, both ways work. The reason I'm slightly preferring the API is just because this returns an array. So it's already in the type we want. So I can go ahead and log selection, for example, and this is just to show us what it's doing. So if I bring up the console, and there we go. So we still have our object there, which I will probably get rid of in a moment. But you see, there we go. We have a selection between 2 points. And if I click, you see sometimes it's null if there's no selection. So first of all, let me just remove the values. And now we're going to deal with how can we create the filter based on this new data. We now have the user interaction. We know we want to filter whatever this range is. How do we set that up? So this is where we're going to start building the filtering module. And this is what I'm going to do. I'm going to have a variable, I'm going to call it time filter, and it's just going to be an array. And we're going to have a whole bunch of different filter types like this. And at this point, you might notice that this is getting a little bit of a lot of different things in the same place. We have the raw data processing and formatting, we have setting up the charts, and now we're adding a bunch of filtering code too. So here I just want to make a quick comment that obviously I'm doing everything in a single file for the sake of example and keeping things simple in terms of the setup and such. if you're doing this in a serious project, this is probably something where you'd want to create multiple classes or multiple modules, or you'd want to modularize it somehow, right? You probably wouldn't want to just put this all in a single file unless you're doing something quite simple. So just to give some general guidance on that, my recommendation would probably be put the data processing in its own file, its own module, and just encapsulate all of that and have everything else call to that when it needs the data. Have the filtering in its own module, so everything we're about to write under the filtering section, have that there, have everything access to that for that, and then finally have the chart set up in its own module. So that'll be my basic recommendation on how you would organize this in a larger project that is, well, requires more organization than a simple example like this. Anyways, now that we have the time filter, there's the matter of setting it. Now obviously I could just go down here and say time filter equals this. I'm not going to do that. I'm actually going to create a function that I'm going to call update time filter, which takes in a new time filter. And for now, it's just going to do this. And the reason I'm doing this is for two reasons. One, in an actual project, this would be a module, and the individual filters would be encapsulated in the module, and something in the charts module wouldn't be directly accessing the time filter and modifying it, and so forth and so on. So accessing this through other methods is a little bit closer to the way things would work in a bigger project. The other reason is once we change the filters, then we are going to want to engage the rest of the cross-chart filtering system. We'll say, hey, a filter condition has changed. You need to now update the way you're filtering the data and generate the new data sets and update the charts and so forth and so on. And if we encapsulate that in a method from the beginning, it makes it very easy to just add in at the end, oh yeah, filters changed, update filters here, filters and data here. And then there you go, no extra considerations or worries. Did I set the filter and not update and so forth and so on. And yeah, so with that, let's go ahead and use that. So I'm just going to say update time filter with, I'll just pass it directly. There's no need to have a separate variable at this point. And really, at this point, actually, I will have a console.log and say time filter changed. And we'll log our new time filter at the end. And there you go. So this should do basically the same thing, but now has a little bit more infrastructure that will help us when we're, actually implementing the rest of the filtering logic. So next, we're just going to do the same sort of thing, except with types instead of just time. So I'm going to have a type filter, which is something like this. We're going to have a function, update type filter, which works pretty much exactly like the one above. And it's going to set the type filter to the new type filter. And again, I'll just actually copy and paste this. Very straightforward. We're going to just log it so that we know what's happening. And then after we've got all this set up, then we'll actually implement the logic here. So this is what we will need for PyChart. We'll want to set the type filter. And the way this is going to work is we're going to need some events. So we're going to need events. And you might be able to guess where this is going. We're going to want on selection change, E and args. There you go. Now in the case of PyChart, we have this very nice variable called args.selection. So if I go ahead and refresh, if I select something, you see, look at that. We have a selection and it contains the slice object for whatever we've selected. And while that's nice in a way, on the other hand, we don't necessarily want this whole slice, right? We just want to know what's the type that I'm filtering. Because ultimately we're going to be modifying the data, or filtering the data rather, and the data doesn't have all the extra slice information, it just has the type. So I'm going to make a slight modification to this. I'm going to map this to x.data.name. And if you look, I will just go ahead and show you. Under the object, one of the things it has is it has the data, which is the original data that was used to construct the slice. And the name happens to be the type, because that's the way we are constructing the data, right? The name's the type. So with that, we now have our new filter, and at this point, we can literally just call the function, and that's that. So, update type filter. There we go. Maybe I can, there we go, format that just a little bit more in view. And with that, I should be able to select things. And now, you see we have an array of just the name. And yeah, there you go. We now officially have our filters set up. So now we have our filter conditions. And that means the next step in cross-chart filtering is the data filtering itself. And this will output multiple data sets for each chart, depending on, well, what filters should or shouldn't apply to a chart. So the way I'm going to do this is I'm going to create a function. I'm going to call it filter raw data. This is going to be our main function. And this is going to have parameters. So to do, add chart parameters. Because, of course, like I just mentioned, this will need to output different datasets, different ways filters are applied, depending on what chart we're filtering data for. But I'm just going to keep it simple now. We're going to not have parameters, and we'll add those in shortly when it becomes clear where they fit into the data filtering picture. So the main thing this is going to do is it's going to return a dataset, like raw data values. And the main thing here is it's going to just apply the filters, whatever filters are appropriate given the parameters that we don't have yet. So we're going to say raw data values dot filter vals, and we're going to take a function that determines whether we filter the particular row or not. So basically we're going through every single row, and we get to return true if we want the row in the dataset, that is, if this row passes all the relevant filters, and false if it doesn't. So by default, we're going to say, sure, it passes all the filters. Let's start with the type filter. So what we're going to do here is, if we remember how this worked in our data values here, if nothing is selected in pie chart, then the type filter is empty. If we have selected something, then we have an array of all the different types that we're supposed to be filtering by. So here's how we can implement this. I can say if type filter dot length, then we're going to implement all the type filter logic. So if the type filter is empty, then we're just going to skip it because there's nothing to filter. Everything's totally okay. So once we are using the type filter, we of course need to know what type this particular row has. So we're going to use the same logic we've had all along, where we're going to take vals, we're going to use the data indices, and I'm going to go by type because that's the relevant one here. And once we have that, the main thing is just, is this one of the allowed types in the type filter? Because if I've selected A, then that means I only want things of type A. If I've selected A and B, I only want type A and B, so forth and so on. So the way we can test this, and this is a very straightforward way to test it, type filter, say index of type. If this is -1, that means that this isn't anywhere in the array. That is, whatever type this row is, it's not in the filter list. So we return false. It's not one of the approved types. And this is a very straightforward way to do it. You could maybe get more creative if you're expecting to have really big, complicated types where this approach might be a problem, but for a straightforward example, this should work just fine. So with that, we do have the filter for the types, at least. We're not actually using this for anything, but we have the filter. Now, if we were to try to apply this function right now, we would immediately run into the problem that we talked about in the overview. Namely, if I click slice A on the pie chart, that shouldn't filter the pie chart. I don't want slices B and C to disappear just because I've clicked on slice A. What if I was about to click on slice B, for example? What if I wanted both of these? This dual filter setup wouldn't be possible because one of the slices would disappear as soon as I click on the other one. So this is why we need to add in the parameter. This is where we definitely need to address this, because we can't have the type filter applying when the data source or the data is for pie chart. So what I'm going to do here is I'm going to add a parameter. I'm just going to call it filter to skip. Actually, I'll call it column to skip. I think that's a little bit of a better name. And what we're going to do is basically we're going to specify one of these data columns where we're not going to be worried about any of the filters applying. So for example, if column to skip equals, say, type, then I wouldn't want this to apply. So I want, if column to skip is not equal to type and we have a filter, only then do I apply it. And naturally, in pie chart, I would pass type as the column to skip because, well, this is mainly displaying type data for filtering purposes. So I don't want this to, well, be filtered out. So now we're going to do something very similar for the time filter, and then we're going to go ahead and apply this function so we can start seeing some of our filtering in action. So what I'm going to do is just copy and paste. We're going to have the column to skip type for date. So if this is not it, and time filter has length, then I'm going to look at the date, and I'll just call this time, I suppose. And then we're not quite going to do the same thing here because the time filter works a little bit different. This is a bit numeric. So one of the things here is actually I want time filter.length and time filter sub 0 is not equal to null. Because it's possible that I select something and deselect it, and look, there's nothing there. So that's another null condition we have in the time case that we didn't have in the type case. I'm going to go ahead and put that on a new line because that's a little bit off screen. And with that, now we just need to test, is this time within range? So is this time, or rather, is it outside of range? Is this time less than the starting time? Or is this time greater than or equal to, because remember, the end is exclusive, so if it's at the exact end time, that counts as being outside the filter. So is it before the start of the filter, or is it after the end of the filter? And if either of these are true, then it's false. This data point falls outside the range we're filtering by, so we don't want it. So now that we have the filter function, it's time to apply it. So first of all, I'm going to delete this comment because we do in fact have the parameter now. And now I'm going to take our function, going to scroll down to our time chart data function first. And you'll notice right now we're just taking the raw data values and generating the values based on that. The way to apply this is very simple. Instead of taking the raw data values, we're going to take the filtered data values with the appropriate column ignored. In this case, since it's a time chart, naturally we want to ignore any filters related to the date column. And with that, if you notice our diagram, we've essentially implemented the main loop in the cross-chart filtering. We now have filter conditions. That's going to the data filter function, which we implemented. And now we're taking the data generated from that function for the appropriate chart and generating the chart data based on that. And that's really all there is to it. So I'm going to go down to pie chart, or technically not quite all, but I'll get to that in a second. And we're going to do the same thing. So I'm going to take raw data values. Instead of that, we're going to use the filtered data values and the ones that are ignoring type. Because, again, that's the main thing pie chart's based on, so we want to ignore that. Now, if I run now, this won't actually do anything. If I select, say, this time range, pie chart doesn't change. And the reason it doesn't do anything is mainly because we haven't told it to. All the logic is set up, but when we update the time filter, we're just changing a variable and doing absolutely nothing whatsoever with it. So the main thing here is we just need to tell the charts, hey, you need to update now because we've changed one of the filters. That's relatively straightforward. There's a little bit of a catch, and I'll talk about that in a second. But let's start simple. I'm going to call this function update filtered data. And what this is going to do is it's going to want to go through all the charts and update their data. This will mean it needs access to the charts array. So I'm going to put this slightly above. If you are making these in separate modules, you might want to think about how this works. Maybe this function is a little bit more appropriate in charts. Maybe the charts are somewhere that's accessible to all modules. Maybe you have some function in some module that makes it accessible. But in any case, it's probably not ideal to have a variable in one module that is accessed in another module. So that's something I would think about. But in any case, right now, what I'm going to do is I'm going to go through the charts here. And there we go. And the main thing here is very straightforward. Well, there's a nuance to it, but we'll start with the simple. The core idea is every chart we want to reload data. Because, hey, we've just had a filter update. So of course, we need to update. We need to change, well, we need to reload all of the data and see if it has changed, because it might be different now that the filters have updated. And that's really the core idea here. So I'm going to go here, and I'll leave the message for now. And we're just going to call this function, and that's pretty much it. So when we update a filter, we will update all the filter data. Let's see what happens. So we've refreshed. Now we have the chart. If I select a time range, you notice pie chart has updated. So it is reflecting which region of data I've selected in time chart. And conversely, if I select part of pie chart, well, then things get a little bit weirder. Suddenly we are in this massive loop of updating. And this is why I said it needs a little bit more nuance than that. So, a couple things here. First of all, when we update one of our filters, we don't want to unconditionally update, because as you see here, if we reload the data and that triggers one of our filter updates, that would cause an infinite loop of updating, reloading, etc., etc. So we only want to actually perform the update if we're getting a new filter. So the way we would want to do this is something like if new time filter, and maybe some like deep equals function, time filter. Now, JavaScript does not have a deep equals function built in. So basically, we want to do the test, and if they are equal, return, just skip it. But as I said, JavaScript does not have a deep equals function, and implementing one is a little bit non-trivial if you want to do it precisely. I would recommend using a library like Lodash. It has a function like this, or something else. Just use an implementation of this. They are out there. For the purpose of this example, we can get close enough with a very simple, not perfectly robust, but it'll do the job for this case, function. So I'm going to create function deep equals a and b, and this uses a classic JavaScript trick. We're going to return json.stringify a, and we're going to test, as you might imagine, does the stringify of a equal json.stringify b? Not a perfect deep equals implementation, but for the sort of data types we have, it will do the job. I would not use this as your general deep equals function if you don't have one. But anyways, we want to do the same thing with the type filter. So we have the time filter and the type filter, and if they're the same, we don't want to go in an infinite loop of updates. So let's go ahead and refresh now. There we go. Now if I click a pie filter, look at that. Now data is actually changing. So actually, let me zoom in a bit. Let's make this, or actually, let's keep the view, but set it as day views, because I think that'll make it a little bit more clear what's going on. And, sure, something like this. If I select A, you notice those have vanished. If I select B, a bunch of those have vanished, and so forth and so on. So it's only showing the ones that are appropriate for the correct type, just like we intended. This isn't quite the end of the cross-chart filtering story, though. There's still two main things I want to cover. The first is an issue of robustness, and the second is an issue of features and capabilities. And I'm going to start with the issue of robustness. So right now, we're reloading every single chart every single time any of the filters update. And this isn't ideal, because you don't want the originating chart to update. In this particular case, it's not that obvious where that might go wrong, but it's much more obvious in some other cases, and it's better to just nip that in the bud before it becomes a problem. Fortunately, it's relatively easy to address. So the way this works is we're going to add a parameter to our update filter data function called origin chart. And basically what we're going to say is if the chart isn't the origin chart, only then do we update the data. This of course means we're going to need to know what the origin chart is when we update the time filter and type filter, and we're going to want to pass that to the update filter data. Also, I can probably get rid of this console.log now. I think we get the general idea. There we go. And with that, I just need to update the calls to actually pass the chart. And this is very easy because of the args.chart parameter. So there we go. And I'll just actually put this on a new line at this point. I think that's a little bit more clear. And same thing over here. We're going to just pass args.chart and to update type filter. And with that, we should now be skipping updating whatever chart actually originated the filter. So if I refresh, excellent, now I can click on the pie chart, and we're only updating the time chart, which is exactly what we want. So there you go. The other thing I wanted to address is right now we are only cross-chart filtering based on selection. If I zoomed in on the time chart to a specific time range, this does nothing. Pie chart just stays the same unless there's a selection. And of course, in the case of time chart, the visible time range is a natural area for additional cross-chart filtering, but in general, it's not necessarily uncommon in these use cases to have more than one interaction which generates a filter of some kind. And that raises the question, well then, what should be the time filter? How do you combine and aggregate those things and make it do something sensible? So I'd like to just use this as an example of how that can work. So in order to do this, we need a new event. We need the onChart update event. And if you remember from our events lesson, this occurs anytime something visibly changes with the chart. So if the user interacts with the chart, that's one onChart update event. And that's a big thing. It only fires one of these when there's some change to the chart. So this is when we're going to want to look at the time range. So we're going to want to use, and there's a function for this, the args.chart target time. And this is going to tell us what time range is visible, or at least what time range will be visible once any animations are over. That's why we're using the target time as opposed to anything else. So if I just refresh, just to show you, right now, it is that crashing? Because I misspelled console. So if I try again, there you go. Now we have the visible time range. And if I zoom in, you see the range narrows because we're looking at a more specific point in time. Same thing here. So there you go. This tells us what time range the chart is trying to display. In order to actually use this though, we're going to need some way of combining this with the selection if present. So let's scroll up and let's create a function for this. I'm going to create a function calc time filter, which will do exactly what we're talking about. It'll take in the target time and the selection, and it will generate a new time filter that incorporates both of them. I am putting this in the filter section. Technically, it might be a better fit for the chart section if you're doing modules, since this is really the only place it's used. It's not really part of the filtering system. But, you know, in this case, everything's in one file, so it's all the same regardless. Anyways, how do we decide what the filter should be if we have both a selection and the time range? Well, one case is obvious. If the selection doesn't exist, so if one of our aspects is null, that means there is no selection, and in that case, our filter is just whatever the target time is. So that's the easy case. The other case where we might want the target time is if the selection is completely off screen. So if I zoom in over here, in this case, selection doesn't apply at all because it's just way off in the distance. So we can apply this sort of test. We can say if selection 0, so that's the start of the selection, beyond target time 1, so the start of the selection way off screen somewhere. Or, and you might imagine how this is going, selection 1, so that's the end of the selection, is less than, I can type it, target time 0. So in this case, if the end of the selection is somewhere way before the beginning of the target time. Either of these cases, selection doesn't apply, we can just return target time. The other case is if the selection is entirely or only partially on screen. So in this case, we need to generate a new filter that sort of combines them both. And so we're going to return this. And the two things we want to take into account is what's the start of selection and what's the start of the target time. And the question is, how do we combine these? Well, really, we want whatever's the bigger of both of them. In this case, the start of the selection is way off screen. We want whatever's the bigger one. In this case, target time. So we're going to want this to be the starting point. And conversely, if the selection start is on screen, in this case, the target time start is way before the beginning of the zone we're really interested in. So we don't want this data point involved. We want to make sure the start in this case is the selection start. So this is just a long-winded way of explaining that we want to take the max of the selection start and target time start. And that's how we're going to combine the starting point. And you might imagine for the ending point, we want the same sort of thing, but we want the minimum. We want whatever is actually smaller for essentially the same reasons. It's just it goes in the other direction on the other end. So, for example, in this case, the target time end is way past the end of the selection. So we want the minimum, in this case, the selection end. That's what we really want. And again, if this is off screen, in this case, the end of the selection is way past the end of the screen. So since the end of the screen is smaller, that's the one we want. So here we're going to just take the minimum of selection 1, target time 1, and that's really about all there is to this. So once we have all that, now all we need to do is actually use the time filter. And since we have a nice function, it's very easy to use. We can just say calc time filter, and we want to combine the target time with our selection. In fact, it's probably easier at this point to just have this in a variable, so I'm just going to set this up here. The range we're filtering is like this. And I will put this in a new line so that that's a little bit, I'll just put them all on new lines so it's a little bit easier to see. And what do you know? There you go. So we have our range, which is the calculated time filter combining both the target time and selection, and that's the amount, or that's the filter we actually give to the time filter. That's what we actually use in our filtering system. And we just want to do the same thing for both of these. And with that, that should, if we've implemented everything correctly, now allow the... Am I still logging something? I don't think so. I think I've deleted that. Yeah. But in any case, now we have selection still, but if I zoom in, you notice that's also generating a filter event. So I can also use where I am in the chart to filter data, and so forth and so on. Look at that. So there you go. And with that, that's really all there is to cross-chart filtering. Of course, you can finesse all the details all you want. You could make more elaborate interactions that do more elaborate filters. You can add more charts. You could make some of this on server side, like I mentioned at the beginning. You can do all kinds of things to your heart's content, but this is really the core idea. None of those are going to change the essential picture of what we have. So at this point, this is a good point to recap what we've done, what we've accomplished, and what we've learned through this journey through cross-chart filtering. The first thing we learned is the big picture. We learned cross-chart filtering can occur when you have a single data source used by multiple charts, and you want interactions in one chart to control what data is or isn't visible in another, and vice versa. And if you do have that set up, then you have a little bit of options on how you go about this. Your cross-chart filtering isn't strictly part of the data, and it's not strictly part of the chart, so it's kind of in a no man's land. You could implement it on client side, you can implement it on server side, it can be closer to the charts, it can be closer to the data. It all depends on what makes the most sense in your use case. But however you ultimately decide to implement cross-chart filtering, wherever you think it makes the most sense, the core picture looks like this. You have some filter conditions that are set by the charts when you do whatever interactions you want to trigger filtering. Once those conditions are set, then the data filtering occurs. If it already has all the data, it might just do it all in memory. If this is server-side data source, maybe it needs to fetch the appropriate data. Maybe some database indexing is used to assist some of the filtering, so some of the filtering occurs in the data lookup itself, maybe. But one way or another, it actually performs the filtering based on the filter conditions. And then it generates data for each of the charts based on the filter conditions. And it doesn't filter the conditions that the chart is ignoring. So that's really the big picture. Now, what this picture looks like once you fill in all the details is something more like this. The data source becomes some setup like this, where you have the data maybe parsed from a CSV file, maybe loaded from a database, but you ultimately get all your data rows, and you get some way of getting the raw data plus some way of indexing it. And that's basically what your data source ends up being, as far as the interface is concerned at least. Then your charts, these ultimately end up taking the data it gets, after all the filtering and such, and then converting that to ZoomCharts format. And that's pretty much the basis of what goes into the data. It gets the data from wherever the cross-chart filtering gives it to it. It converts that to ZoomCharts format, and there's the data for the chart. Very straightforward. Once you actually have the data, then there's how do you generate filter conditions. So here you have events, and when the event is triggered, like say a selection is set, that says, okay, now we need to update the filter conditions to account for this selection. And same idea in time chart. Once we have selected something, for example, that triggers an update to the filter condition. Or once any chart update at all has changed, if that changes the target time, that is, if that changes the range of time we're trying to display, that's another filter condition change. So you have ways of detecting what's happening in the chart, and does that mean we need to change what is being filtered? Once you have that, though, then you actually apply the filters. So this is as simple as we set the filter condition appropriately, and we apply the actual filter data with the filter function. So the data filtering literally just takes the raw data. So here is the data values from the data source, and it applies a filter. At least in our case. You can make this more complicated. You can use different ways of approaching this if it makes sense in your use case. Like maybe, again, if there's a server side, probably using the filter isn't ideal. Probably there's some functions you have in your database that can do some of this filtering. But in any case, we have the data filtering. It's taking the raw data from the data source, it's applying a filter. And this is literally just taking our filter conditions and saying, does it fail the filter condition? If not, don't include it. If it passes all the filter conditions, it's in. Very logically straightforward, though as you saw, there are some details involved in making this happen. And of course, it pays attention to what it should be skipping, because each of the charts is going to have one column it's focused on, and that's what it wants to skip. So if we're trying to skip a column, it doesn't do that, and that's how it generates the different data sets for the different charts. And really, that's about it. There's the one hidden detail, quote unquote, where once the filters have updated, you do actually need to reload the chart data so that the charts have the new filter data. Except, of course, the origin chart, because if you did that, that would cause some weird behaviors in some cases. Namely, like losing your selection if it reloads and the selection goes away, for example. So, yeah, it can cause some odd effects if that happens. But anyways, that's really the big picture of cross-chart filtering. That's a detailed example of how this sets up, how you set this up, and how all those details shake out relative to the big picture. And hopefully that gives you a good idea of what goes into this and how you might go about this if you're going to implement something like this. And even if you're not, at least it gives you an idea of how some of the features of ZoomCharts, like say data functions, events, data loading, processing data from a file, not strictly a ZoomChart feature, but something you will be doing in every use case you encounter, processing whatever data source you have. Hopefully it gives you some idea of how all those details might fit together in a more elaborate use case than some of the examples we've seen so far. With that, that's just about everything for this video. Thank you very much for joining me, and I will see you again. Until then, have a wonderful time applying ZoomCharts and using your bootstrapped knowledge to make awesome things with native SDK. Till next time.